Welcome to January 5th's LeetCode Challenge, Palindrome Partitioning. Given a string S, partition S, such that every substring of the partition is a palindrome. Return all the possible palindrome partitioning of S. A palindrome is a string. A palindrome string is a string that reads the same backwards as forward. So, given the input S, partitioning, we have AAB. We want the output is going to be A, comma B, comma A, comma B, and then AA, and then B. So these are all the substrings that are palindromes, meaning that they can read forward as they do backwards. So keep in mind that single letters are fine, and if you have two A's in the string partitioning, and the original string, then they count as individual strings here, individual letters. If you're given one letter, then we have itself being a palindrome, because a single letter could be a palindrome by itself. So our constraints would be the size of S between 1 and 16. S only contains lowercase English letters. And yep, there you go. So there's a couple of things we should keep in mind here. The first thing is that we could probably solve this using a backtracking algorithm or depth first search type approach. That is for sure. We could always, move one forward to find if it's palindrome and then move it backwards. That is one approach we could do. We could also use dynamic programming as well. We actually combine those two together. So I'm going to try to aim for a dynamic, a purely strictly dynamic programming approach, and see where we get from there. So the first thing we want to do is kind of think of a game plan here. So we want to develop a a dynamic programming array that holds the index, which stores all the possible partitions of the string from the slice in the beginning to I. So we want that to be the case where the condition is going to be where the dynamic programming array at index slice of the beginning to n would be the desired output. Desired output. Right, and that's something what we want. So you want to have a dynamic programming array that stores all the possible partitioning of the string S, and the dynamic programming at the index of the slice between the beginning to n would be the desired output of what we want. So that will be hopefully a palindrome. Right? We don't know it yet, but that's what we're going to hold. So if that's the case, we're going to develop our dynamic programming array as such. We see inside the structure here, it's going to be an array. So the first thing we want to do is develop an array using a list comprehension here for blank and range of the length of S plus 1. Alright, that's a dynamic programming array being initialized. So the first thing we want to do is find if there are no possible partitionings existing, then we want to return an empty return nothing, because if we're giving if this function called S here, which is a string, if there's nothing in it, then we have to return empty string. So no possible partitionings with 0 elements. Alright, and therefore the list is empty, so therefore the dynamic programming array at index 0 is going to be an empty list. Oops. There you go. So we got that. We got two things out of the way. We developed our structure. We found the case if there's no partitionings available with 0 elements. So there's going to be empty list of lists, just to make So the goal is to the objective, I should say, is to finish with index j. So we're going to develop two indexes going from j, I and j. where j is the second index. So finish with index j going to an n value or a specific value inside at the very end. At the end. So we're going to develop a nested for loop here to have basically the objective is to find, so to move our j index to an n value where we are going to have a palindrome. Alright, hopefully a palindrome. So we're going to develop a nested for loop. So for j in the range between 1 to the length of s plus 1, because we need to keep track of, and then for I in the range of j minus 1, going in reverse order by -1 elements. I mean, going by -1 elements in reverse order, I should say. So the condition is that we need to know if it's palindrome or not. So to know if it's palindrome, and it must satisfy this following. So the string between s to j, this is a slice of the string between I to j, I should say, doing it within our nested for loop, has to equal the reverse of it. Basically, it'll be the string, the slice between I to j going in reverse. There you go. So this is how we tell if the condition is a palindrome. If it is, we want to add the new palindrome to all the different partitions of S slice between the front to I. So if that's the case, you want to basically add the partition. How do we do that? We need to make a new partitioning array. So I'm going to name this partition 2j. And that's going to be empty to begin with. Then we're going to add some stuff to it. So so we initialize an empty array list. So if we take the partition from whatever index I to j, so we have another for loop here. So the partition is going to be from I in the dynamic programming array at index I. So call it partition of I in the dynamic programming index at I. We are going to find whether we should add the slice to the partition or not. So we need to have, since we have partition of I, we do partition of j, and that's going to be partition of I plus, this is a concatenation here of the slice of the string between I to j. And then we want to also append, so first of all, we add the partition to the list here. No, we make it equal to partition of j, then we add it to the list. So partition to j dot append, and we're going to append the partition that was partition of j, because we just set that off here. And then we want to exit the for loop here. And then we have, since we're using the dynamic programming index I here, and within the for loop, next thing we need to do is exit the for loop and do the same, do a similar extend the index of j. And that's going to use the partitioning to j. Alright, all that to say that we need to return the last index of our dynamic programming array. Alright, let's run this. looks somewhat good. Wow, that worked. So that was actually pretty tough. I would say that so the time complexity is big O of n squared. Um, hmm, n cubed maybe, because we have just two for loops, and then this for loop right here, n cubed. Let's go with that. The size of the space complexity is big O of n, because big O of n squared, because we have a dynamic programming array which holds an array of an array. Yeah, there you go. The only complex part I would have to go over again would be this part right here. Let's see, how would I describe this in order for it to make sense? Actually, the time complexity is actually big O of n times 2 to the n squared, I should say. That's the time complexity. And space complexity is big O of n. Let's see. Well, I mean, the code's there. Not the best at explaining it, but there you go. Have a great day, guys.